With the increasing use of electrical equipment, electronic monitoring systems, and the introduction of the microprocessor, a new opportunity for electronics is being used in machines. No longer are the electrical systems separate from the engine, powertrain, and implement systems. Now the electrical and electronic systems are integrated into the entire machine, controlling the engine, transmissions, and other vital machine functions. With the importance of electrical components in today's machines, it is critical to keep the electrical system functioning to keep the machine operating. A machine failure could cost the customer a lot of time and money. With the increasing use of electrical equipment on machines and implements, many connectors of all types, sizes, and shapes are being used. With this widespread use comes increased maintenance and repair of the connectors and their associated wiring, pins, and sockets. In this video, a number of key points will be covered: the characteristics of the wire, proper wire preparation, crimping of VE, SureSeal, and Deutsch terminals to the wire, the identification of the different types of connectors, the assembly and disassembly of various connectors, proper testing of connectors to ensure a good connection, and the interpretation of connectors and wiring from electrical schematics. Wires in an electrical system provide paths for current to flow. Wires used in electrical systems are commonly made of copper because of its good conductivity and relatively inexpensive price. They are sized according to the American wire gauge standards. The size of the wire is a function of its diameter. To simplify sizing, the AWG standard has applied numbers to the various diameters of wires. Using only even numbers, small wires have higher numbers, typically starting at 20 gauge wire. Large wires have smaller numbers, down to 2/0 wires. Caterpillar generally uses 14, 16, and 18 gauge wire in most electrical circuits. All conductors offer some resistance to the flow of current. Resistance depends on the length of a wire, the cross-sectional area of the wire, and the temperature of the wire. The longer the wire, the greater the resistance. The smaller the wire diameter, the greater the resistance. The hotter the wire, the greater the resistance. When replacing wire, it is very important that the same type, size, and length of wire be used to assure identical performance characteristics in the circuit. Using a larger gauge wire could damage components and add weight to the system. Conversely, using a smaller gauge wire could cause the wire to heat up. Wires are normally surrounded by an insulating material which isolates the wire. In confined areas, insulation keeps the current traveling through the wire and not to an alternate path such as another wire or the machine frame. Wire insulation is usually color-coded and stamped with an identification number to aid the mechanic in tracing wire through a circuit. These numbers and colors, along with a system schematic, are good troubleshooting tools to use when diagnosing problems in a circuit. It is important to inspect the insulation of the wire very carefully for cracks, splits, burns, or any defect that could cause a short in the circuit. A thorough inspection of the wiring will not identify all the potential problems in the circuit, but it is a good starting point in the troubleshooting procedure. It would be impractical to use one length of wire to connect two components in a system if the components are far apart or if a component must frequently be disconnected and removed. Thus, in most circuit applications, connectors are used to join wires. The purpose of a connector is to house the pins and sockets to allow the wires to be quickly disconnected and reconnected. Connectors have two mating halves which fit together. Most of the time, one half of the connector houses the pin contacts and the other half houses the socket contacts. The exception to this is the SureSeal connector, which contains pins and sockets in both halves of the connector. Regardless of the connector, when its halves are mated together, the pins fit inside the sockets and make contact, thus enabling current to flow. Pins and sockets are used in connectors to conduct the current continuously from one wire to another. The surface of the pins must contact the surface of the socket to make a good path for current flow. With the naked eye, the surfaces of the pins and sockets appear very smooth. However, a closer look reveals microscopic peaks and valleys, a condition known as asperity. When the pins and sockets are mated, only about 1% of the actual surface areas are in contact. This limited surface contact reduces the path through which the current can flow and increases resistance in the circuit. Asperity can be reduced by plating the pins and sockets with a softer material, which smooths the peaks and valleys and provides more contact area, thus reducing resistance. Both Deutsch and SureSeal terminals are plated to help reduce asperity. Occasionally, pins and sockets must be replaced. The following equipment is required to replace terminals: wire strippers, a proper crimping tool, pins, sockets, and wire. First, cut the old contact from the wire with the 6V3001 crimping and stripping tool. Be sure to cut the wire square. The next step is to remove the insulation from the wire. To properly perform this step, the gauge of the wire must be determined. Unless the gauge is printed on the insulation, you must refer to the wiring diagram or electrical schematic or measure the wire to determine the gauge. After the gauge is determined, simply match the gauge of the wire to the proper hole in the stripping tool. Insert the wire into the tool and squeeze the tool closed to cut the insulation. Next, open the tool, rotate the wire 90 degrees, and squeeze down again. Then, with the tool still closed, pull the wire from the pliers to remove the cut insulation. The amount of insulation to be removed from the wire depends on the type of terminal pin or socket being used. Two main types of terminals are commonly available: closed barrel and open barrel. With closed barrel terminals, the wire should be stripped so the wire will bottom in the terminal with the insulation about 1.5 millimeters or 1/16 of an inch from the end of the terminal. Open barrel terminals require that both the wire and the insulation are crimped in the terminal. Measure the amount of insulation to be stripped by holding the wire next to the terminal to be crimped. The amount of insulation removed is approximately 4 to 7 millimeters or 1/8 to 1/4 of an inch. After the insulation is stripped, inspect the wire for any nicks or cuts which could lead to a potential failure or high resistance in the connection. Do not twist the exposed bare wire strands. If the strands are twisted, they will overlap and not align parallel with the terminal. Some of the strands could be cut when crimping the terminal. If any wires are cut, the terminal should be removed and new terminals should be installed. Open barrel connectors are used both in SureSeal connectors and VE connectors. Crimping open barrel connectors is a two-step procedure. First, place the small U-shaped opening of the contact in the small crimping jaw labeled B. Make sure the opening of the terminal barrel is facing the letter stamped on the tool. After removing the insulation, position the wire in the U-shaped channel of the contact with the stripped end of the wire completely in the small U-shaped opening. No part of the insulation can be in the small U-shaped opening. Hold the wire in position and squeeze the tool handles to complete the crimp. At this point, the contact should have both flanges folded over the wire with no insulation in the crimped area. Now, the insulation must be crimped in the barrel. Position the large U-shaped portion of the terminal in the large crimping jaw labeled A. Make sure the opening of the barrel is facing the letter stamped on the tool. Hold the insulation and wire in position and gently squeeze the tool handles to complete the crimp. Be careful not to overcrimp or the terminals will crack and cause continuity problems. After the completion of both crimps, inspect the terminal for proper crimping. The larger flange should wrap around the insulation and the smaller flange around the wire. On SureSeal terminals, Caterpillar recommends all terminals and wires be soldered together after the crimp is completed. Soldering helps prevent the terminal from breaking when it is inserted into the connector housing. Always use rosin core solder when soldering the wire to the terminal. The Deutsch connector terminal is a closed barrel which requires a 1U5804 crimping tool. First, set up the tool for the proper wire size to be crimped. To adjust the tool, remove the lock clip and lift the black dial. At the same time, turn the dial until the arrow is aligned with the size of the wire to be crimped. Lower the selector knob into the detent and reinsert the lock clip. Next, loosen the lock nut and turn the blue adjusting screw in until it stops. Insert the pin or socket contact into the crimping tool with the barrel facing up. Then, turn the adjusting screw until the contact is flush with the cover of the crimping tool. Close the handle of the crimping tool just enough to hold the contact in position. Make sure that the contact is centered between the crimping indenters in the tool. Insert the wire into the contact and close the handle completely. Release the handle and remove the contact. After the terminal is crimped onto the wire, inspect the terminal to make sure that all wire strands are in the crimped barrel. On a Deutsch terminal, make sure that the crimp indent is in the center of the terminal crimped barrel. Make sure that the copper wire can be seen through the inspection hole in the terminal, which ensures the wire was inserted completely into the terminal. Also, pull the wire slightly to make sure the terminal has been crimped completely. Sure-Seal connectors are a rubber molded design that ensures that they will always mate correctly. One half of the terminals in the connector are installed in one direction and the other half of the terminals are installed in the opposite direction. These terminals are currently being used on many Caterpillar machines. To remove a contact from the connector housing, simply pull on a wire that is connected to the contact. Sometimes insufficient wire is available to pull the contact out, or the wire may not be connected to the contact. In this case, a pin contact can be removed from the housing with a needle nose pliers. If the wire is not fastened to a socket contact, push the contact out of the connector housing with an insertion tool, or use a rounded 3 mm or 1/8 inch diameter rod. Installation of a contact into the connector housing is the same for all Sure-Seal connectors. To install a connector into a Sure-Seal housing, a wire crimped with a pin or socket connector and the 6V3008 contact insertion tool are needed. Alcohol should be used to lubricate the insertion tool. Never use commercial lubricants on connectors. Make sure the plunger extends past the end of the tube. Dipping the tool in alcohol and a slight twisting motion will aid in the insertion of the tool. Make sure that the tool is inserted in the correct end of the connector. With the tool completely inserted, pull the plunger completely back. Then, insert the new contacts into the tube of the tool until the contact stops against the retracted plunger. Now, hold the wire and connector body together and slowly twist the tool out of the connector housing. After removal, the contact may be shifted and extended beyond the surface of the rubber in the connector housing. If this occurs, pull on the wire until the contact is even with the end of the housing. To ensure compatible pin and socket connections, the connector is labeled. The wire must be connected to the correct pin or socket to provide the correct electrical path for current flow. Any holes not used for contact assemblies in the housing should be filled with the 9G3695 sealing plugs to provide complete protection to the connector. To install the sealing plugs, push the plug into the end of the connector until the head of the plug seats. Deutsch environmentally sealed connectors are available in many shapes and sizes. Deutsch connectors are the primary connectors used on Caterpillar machines because of their durability, easeability to maintain, and also because of the variety of styles the connectors come in. The DT series designation stands for Deutsch Transportation. These contacts are rectangular or triangular in shape and made of thermoplastic. The parts of a DT connector are the pin connector housing, the socket housing, orange receptacle wedge, orange plug wedge, and plug seal. The DT connector plug contains a locking latch. To unseat the latch, depress it and pull the connector apart. The larger DT connectors contain two latches which can be easily depressed with your thumb and forefinger. To remove pins and sockets, disconnect the halves of the connector. Remove the orange plug wedge from the plug housing with a thin blade screwdriver. With the wedge removed, place the screwdriver against the terminal locking finger. Pull the finger away from the terminal while gently pulling the wire out of the connector. To remove the pin terminals, remove the orange receptacle wedge. On the 3-terminal DT connectors, the wedge can be removed by grasping it with a small needle nose pliers and pulling the wedge out. The other wedges are removed by grasping the center of the wedge with the 9U7247 wedge removal tool and pulling the wedge straight out. With the wedge removed, use a small screwdriver to pull the terminal locking finger away from the terminal while pulling the wire out of the connector. To insert a wire into a DT connector, remove all the orange wedges from the connector. Hold the wire near the crimped terminal and push the terminal into the rear of the connector until you feel the terminal lock in place. The socket terminals are inserted into the plug housing, and the pin terminals are inserted into the receptacle housing. Inserting the socket into the plug housing first ensures the correct terminal installation. A slight tug on the wire will confirm the terminal is correctly locked into place. After all the terminals have been inserted into the housing, secure the orange locking wedge into the connector until it snaps into place. Needle nose pliers may be required to insert the receptacle wedge on 3-terminal DT connectors. Any holes not used for contact assemblies in the housing should be filled with 8T8737 sealing plugs to provide complete protection to the connector. To install the sealing plugs, push the plug into the end of the connector until the head of the plug seats. The HD series connector is a heavy-duty circular connector which is made of thermoplastic. The HD10 connector consists of a plug half, a receptacle half, and a coupling used to lock the connector halves together. To disconnect the HD connector, turn the coupling while holding the connector and pull the halves apart. A special keyway pattern is designed into the connector to prevent incorrect assembly. Assemble the connector by butting the two halves together and rotating the halves until the connector slides together. Rotate the locking coupling approximately 1/4 of a turn. When a click is heard or felt, the connection is then complete. Terminal insertion into the connector is the same as for the DT connector. Slide the pin or socket into the end of the connector until a small click is heard. At this point, the contact is locked into position. A slight tug on the wire will confirm that it is locked in place. The contact removal tool is used to unseat the locking fingers inside the connector, which allows the wire and terminal to be removed. The contact removal tool for the HD10 connector comes in 2 sizes applicable to Caterpillar equipment. The blue plastic tool is used to remove 16 to 18 gauge wire, and the green plastic tool is used to remove 14 gauge wire. Slip the appropriate size plastic tool over the wire of the contact to be removed. Slide the tool straight into the connector along the wire until the tool bottoms and resistance is felt. The tool will unseat the locking fingers and allow removal of the terminal. Pull the removal tool and the wire out of the contact together. This graphic shows an inside look at how the locking fingers grab and hold the contact in the connector. When the removal tool is inserted, it pushes the locking fingers back and allows the contact to be removed. Minimal effort is required to remove a terminal, so if resistance is felt, make sure the contact is completely seated into the connector. Do not turn the removal tool when it is in the connector. This could break the fingers in the connector or break the tool. The DRC connector is a Deutsch rectangular connector, which is a 24, 40, or 70 pin rectangular connector made of thermoplastic. The DRC connector consists of a plug envelope and a receptacle envelope, which are connected together by a jack screw. This connector uses 16 gauge wire, which is removed and installed identically to the HD10 connector. The same blue contact removal tool used with the HD10 is used with the DRC connectors. The term CE designates Caterpillar environmental connectors, which are circular and made of metal. CE connectors are made by Deutsch specifically for Caterpillar and are used primarily for machine control units. A CE connector consists of a plug end, a receptacle end, and a coupling used to lock the connector halves together. The CE connector is similar to the HD10 connector in the way it is assembled, disassembled, and in the procedure for removal and installation of terminals. However, the contact removal tools for CE connectors are different than for the HD10. Caterpillar uses two contact removal tools which are color-coded for wire size. Yellow for 12 to 14 gauge wire, and black for 16 to 18 gauge wire. These tools are not interchangeable with the contact removal tools for the HD10 connectors. Always consult the manufacturer's instructions for the correct tooling application. The CE connector has a back shell that covers the wires and secures them with the use of a tie wrap. To install the back shell, screw the shell onto the back of the connector and install a tie wrap to secure the wires. The term VE designates vehicular environmental connectors, which are circular, made of metal, and similar to the CE connectors. Deutsch CE connectors are replacing VE connectors on all current Caterpillar machines. However, you may still find VE connectors on older Caterpillar machines. The major difference between the CE and VE connectors is that the VE connectors require special removal tools to extract a wire and terminal from the connector. With the proper tool, the removal is the same as described for the HD10 and the CE connectors. Do not use these metal removal tools on any other application since they may damage the connector. The VE connector has a threaded back shell similar to the CE connector. This back shell covers the wires and secures them with a screw-down harness clamp. Some connectors used on Caterpillar equipment are required to meet military specifications and are called MS or MIL style connectors. While these connectors come in many shapes and sizes, most are round and consist of a plug half which contains the sockets and a receptacle half which contains the pins. At the end of the pins and sockets in an MS connector is a small solder pocket. Insert the stripped wire into the pocket and apply heat with a small pointed soldering gun to the underside of the pocket. Always use rosin core solder when soldering the wire to the terminal. An electrical schematic is one of the best troubleshooting aids a technician can use when diagnosing electrical system problems. Schematics contain a wealth of information for those with the ability to read them. Being able to find wires and connectors and trace through the circuit requires the technician to decipher the schematic as well as relate it to the actual machine. Shown here are the basic schematic symbols for electrical wiring and connectors. Wires are represented by lines and are labeled by circuit number identification, wire color, and gauge. This information corresponds to the information printed on the wire insulation. The number on the wire represents the circuit the wire is used in, as well as the function of the wire. Use the wire description chart on the schematic to identify the wire's circuit and function. The color of the wire depicted on the schematic is used to identify different circuits in the system. These colors are identified in the legend on the schematic. Note that the circuit colors are not the actual colors of the insulation on the wire. The actual color of the insulation can be determined by looking at the wire number and reading the two-letter abbreviation for the color. Many schematics are printed in black and white, so always use the wire color listed in the identification number to identify the insulation color. Sometimes, the wire gauge is omitted in the information code on the schematic or the wire. If this occurs, refer to the note on the lower right corner of the schematic. Pins and sockets are represented by these symbols and, when associated with a connector assembly, they will be enclosed in a rectangular box. Note that each pin and socket combination is identified by a number or letter which corresponds to the number printed or stamped on the actual connector. When wires are bundled together, a thin black line is used to represent the bundle. This designation reduces the number of wires drawn on the schematic to minimize confusion. In this video, a number of key points were covered: the characteristics of the wire, proper wire preparation, crimping of VE, SureSeal, and Deutsch terminals to the wire, the identification of the different types of connectors, the assembly and disassembly of various connectors, proper testing of connectors to ensure a good connection, and the interpretation of connectors and wiring from electrical schematics. We hope that the information provided in this videotape is helpful to you in preventing unwanted electrical problems due to improper wire maintenance.